So, hello, good afternoon, and a very warm welcome to all followers we have here to our second video session. We'd like to show you now our nice charging test system. In this video, we'd like to present the EVSE side. So, first of all, I'd like to introduce myself. I'm Bernd Baranski. I'm one of the writing members of the first 15.11.8 team of the ISO norm, but I'm also in touch with the guys who write the DIN spec 7121. And since more or less 5 or 6 years now, I'm mainly involved in testing charging systems, charging spots, cars, whatever, and also doing test cases according to the test norms of the ISO 15118-4-5 and also the DIN spec 17122. And I'm here with
Evgeny Kühn. I'm one of the developers at EC-TESTS-EVSE, and I joined this team a few years ago, and I'm here to present it.
And we now like to introduce you our nice test system. It's coming in this tiny box, and we have here the metal case with some drawings on. The connection to the CP line is via the banana plugs. We have here PE, we have the red one is PP for the resistor, and the yellow one is CP. CP and PE is also connected via this BNC plug. We have here some lightnings for status and things, and also the on-off switch. On the back, you find the IE64, which is the plug for the PC LAN connection, and also the power supply for this. So we put it here now. We have the both banana plugs, which is connected to our test device here, which we have, which we will explain later on what we are doing. Here, the hardware is connected, and now we can start the software. The ones of you who have seen our first video where we tested the EV side, this software might be well known, and also for all the others which are not familiar to the charging communication, please watch our first video, which is linked here on the LinkedIn and also on the Xing website. On the other hand, you can find it at Eclipse Signer. In addition, you can find us also on YouTube, so there's a lot of ways to find the first videos we have done for the EV presentation, because in this we have a short introduction into the charging communication and all, which we now skip because this is part 2 of the explanation of the test system, so we didn't start again with the basics. So what we have here in our window is on the right side, we have the communication log window where you can see the states. For if the test cases are running in the state window, you can see which part of the software is actually executed. On the bottom of window of this message window, you can find the commands which are executed. It's more or less similar to the ones of you may know this tool Wireshark, where you can see really the communication itself. On top, you have BWM sign where you can go to the manual page, where we have here, first of all, the device setting, which is the IP address of our test system, which is connected. You can see also the host device and the MAC address and also the version of it. And on the left hand, you can see if the system is running, you can see the measured CP frequency as also as the duty cycle. But due to the fact that this is a kind of a manual page, we have on the right side these buttons where you can change, for example, the CP resistor to change between the states A, B, C, and also the PP resistance, which is responsible for the current possibility on the power line on the real cable. So if you have a, for example, 32 amp cable, there's a different resistor than for a 16 amp cable. And we have the positive and the negative voltage for the PWM signal so that you can play around. For example, if you have a charging spot which is able to communicate with PWM only, you can here test the limits where the charging spot is, for example, switching from A to B or from B to C state or back and vice versa. As also you can check if the measurement of the PP resistor is done wrong or right inside of the charging spot. So we have a lot of manual features, and also these manual features could be used on another page where we have the input values, the settings input values for the testing. If we go to this, we can also change these parameters to run all test cases with different parameters. In addition, there are some AC charging spots, meanwhile, which are able, like the one which we use for test, which are able to communicate also with PLC on PWM signal. So you can, for example, if you don't know if your test device is able to communicate with PLC because it's a closed device and you have only the Type 2 plug to connect the charging spot to your test system, and you don't know what's inside, you can play around here with the PWM and get the test device to state B, and then you go to the Slack window and you can start the Slack EVSE, for example. So in this case, now we start the Slack PEV because we are the vehicle in this session. So we test the charging spot, the EVSE, and we simulate the EV with our test system. So you go to state B, and if you start the Slack PEV, means that our test system is sending out a Slack request, and if there is any kind of PLC device, hardware and software inside of your charging spot, you will get an answer, and at least the Slack should run in this case without any problem, so that you know, okay, my test device is able to speak PLC or B2G, however you want to call it. So you can really start with the test. It's just for a pre-check of charging spots which you are not sure if everything is equipped as you are promised to. Okay, on the left side of the software, you can see the settings also for the test cases. We have at first the test report where you can enter the name of your test, the name of the person who is doing the tests, hardware software version of the test device, also hardware software version of our test circuit, and we have a lot of possibilities to change the setup. For example, here we have the ports which could be changed. We have the TCP IP addresses. We have the MAC addresses. We have a lot of things which could be checked or could be changed here. But this is just for communication. If you have the plug and charge possibility you want to test, we can here go to the certificates, and you just uses your certificates or which certificates ever for the whole test cases. If you want to test the plug and charge feature, you need to have the certificates, of course, otherwise it's not possible to run the test cases. Then we have the PIXIT. In this, there are several hardware-related things. They are also described in the test norm in the ISO 15118-4-5, as also as in the DIN norm. There are the PIXITs, and also here we have, for example, the capability of the PP resistor. You can use AC and DC test cases. You can write in maximum currents for the power control if you are checking DC charging communication. There are lots of things which could be introduced here. These PIXIT values which you put here inside will be also attached to our output file, where we check or if the test case is over, or if all test cases are gone, you get a report, and inside of the report attached you get also all the PIXITs you have used. So if you have done anything wrong on the PIXITs, you can check it also in the test report. So we have also a timer window where the first and important thing is the time between two test cases. That means one test case is finished and your device under test, or all devices under test, needs different time for starting the next new test case. So for example, you have some charging spots which are very quick. You can then go down to 5 seconds, and if they last a little bit longer than our system here, we have here 15 seconds, but you can enter also timings up to 6-7 minutes, depending on, for example, any Linux timeouts which are used, or HMI timeouts, or whatever you have in your system. It is possible to put a number here which is related to your system. Okay, in case of you need always 7 minutes between two test cases, it could take very long to run all the needed test cases at once. Maybe you can run them then overnight, or I don't know. But nevertheless, it's possible to put here very interesting numbers in. Okay, so then we have the parameters for security and for modem addresses and things, but that's then all for the settings for now. So we have everything in here, and then what we want to show now, because in the first video we were a bit quick in this part, we want to show now how to create a test session. So for the test session, Eclipse Signer offered several test packages. One is the Slack, one is V2G communication, which is ISO 15118, or it's called, I guess, interoperability somehow, and also the DIN test cases, always for the EV and the EVSE side. You can get either both or only one of those, depends on what you need. And all the test cases which are possible for your test system, which you have bought by Eclipse Signer, you can find here in this window. So in this case, for example, we open the Slack Common test cases, and you can see on the right side a list of all test cases which are implemented for Slack Common. And if you want to use one of those, for example, Slack Match, you just book the first test case, and you have a short description of the test case itself, coming out of the norm, or the text is nearby to the norm, what's written in the norm, so that you can always check if this is the right test case you want to do. For example, if you are a software developer and you are just developing actually the Slack Match function, you only need the Slack Match test cases, but maybe you have also session setup. Then in another session, test session, you put all the session setup test cases in, so that whatever you are just programming, you can fit the test cases to your needs. Okay, so yeah, we have V2G AC and also V2G common and V2G DC. So a lot of test cases are here involved. We have already prepared a test session just to show you, because otherwise we may not fit or find all the tests we want to show here. We have prepared a little bit of test cases, but in this now I want to show you what we have here as a test device. Our test device here is a self-made charging spot, which is Phoenix Contact EV charger controller. This one is made according to the IEC 61851-1, which is PWM only. Is connected via an EVSE powerline GP module, and this powerline GP module gets the PWM signal as an input, put the PLC signal on top, and then both as an output towards the CP line. We have a Raspberry Pi inside of this test box for us. There's the DIN and the ISO stack. And now we want to show you the test cases. We can have a look here and run the test case, and you can see also how the states are changed and the messages are coming and so on. So in this case, for example, we have only a Slack test case. In the Slack, you have only one step to the Slack messages which are running, and you can see in the window below the single parameters. You can see the source MAC address, you can see the message type, you can see the message names, and also if you click on the messages itself, you can see the content of the message, so that you can follow the full test case. Okay, so first test case is done. We have two additional test cases for Slack. In this case, we variate the content of the messages, which are called attenuation characterization. So there are normally more than these two test cases, so that you can vary and a lot of more data than we have. But here we want only to show the possibility and the run of these test cases, because we chosen this table of tests just to have a few ones out of each from the OSI layer model, where we have in the basic two lines the Slack communication, and then it goes up via UDP, V2G, and EXE and so on to the upper OSI layer. So what you can see here on the left side, where Slack is written, this is still the lower level of the OSI layer model of the communication itself. But when we go, for example, now we have a charging status, so where we go really to charge the car, and there you can see that there are a lot of more communication is needed till the main release is closed and the power is delivered to the car. So here we can see there's a ramp up of all the communication, and on the left side you can see the full commands which are running in the communication. Of course, you can also see in the lower window of the test all the commands which are used in for this test case. So the next steps we have here planned is the charge parameter discovery. But now this charging status test cases failed, because we have there a very long timeout which needs to be waited off. And in this case, okay, I know already what happened, because we have prepared everything for this presentation. So in this case, the timeout is not reached, and that's the reason why we have here red test case. But we will see in the later presentation of us when we create the test report, we will analyze where the problem is coming from and what you see in our test reports. So the next one is the charge parameter discovery. And if you click on, for example, on the test case itself, you can see a short description of the test case itself, which is more or less the content out of the norm, that you can see what happened in this test case. If the list is very long of your running tests, this could be the case that you come back to the test system and you don't know where you are in your test session. So here you can have a look what is actually running, which test case is happening, and which test is performed in this. Jeff, you can explain the states here, what we have.
So what we have here are the different messages that occur that we can see also in the bottom block, and each dot is a successful change of a message or a state, while the red squares represent something went wrong and some time was not reached or something didn't happen, and those represent the errors. And we can see here for each test case we have time in between, 15 seconds timeouts in between test cases, and otherwise all test cases we can zoom in, we can zoom out how much we want and see the whole picture, or like go into it rather than go through the log at the bottom. This was, for example, a test case that had a pretty long timeout where we waited for the termination timeout, and so this one was pretty long in the runtime.
Okay. So actually we are on the service discovery test case. In general, the test cases out of the test norms are are organized in a way that the lower numbers are more or less the good cases, and the higher numbers are variants of parameters of single commands. That means if you have, in this case, for example, service discovery, the test system runs to this command till this service discovery happen, and then it changes, for example, data inside of this test case to check the reaction of the device under test. So for each data, there's a range of values which are valid and other values which are not valid, and things which are not allowed, and so on. And all this different behavior is here tested in all these special test cases. Here, as I said, this is service discovery. So we have here actually an ongoing test. And after this 2 test cases, we have done the session, and we can have a look at the test reports. Actually, can you go to the bottom of the what happened? Okay, so we are more or less now in a wait state for finishing one test case and running the next test case. That's the reason why also in the upper window nothing happened actually, because we have this 15 seconds timeout between the 2 test cases, so where one is finished and the other one just started. So, but of course, this 15 seconds could be changed by anything else if your device is much more quicker than our ones. So
once it's finished, we can create a test report and check the test report.
The test report now, no.
We just wait till it's finished. It's 15 seconds after the test case. because the 15 seconds starts after we disconnect the device and there are some ions in the test case itself. So it's always it can always take longer than the 15 seconds that are prognosed in the wait for next test case. For example, this one waits for the connection termination timeout.
Yeah, and it's gone now. So we have the connection termination timeout, and now we will have a look on the test report.
So we created the test report.
So have a look at the structure here. We have a report in XML, and these XML reports are well known to be used in different other test systems where you can store it, like in Jira, you can put the reports, and in other test cases in databases and so on, we can use the XML command to get them ready. And now we open the report to have a look. In the report, you can see we have, first of all, the data, the dates itself, and the name of the test session, the name of the guy who is testing, the version of the device under test, and also the version of our test and simulation system. In our case, we have prepared 9 successful and 1 failed test cases. If you go, for example, to the Slack Match test case, it's jumping to the result window where you can see again the name of the test case and the description what it's done. And also you can jump to the XML where we have logged all commands which are executed and received and requested, so that each command and each content is shown here in this list of these test files. So it's more or less a log file similar to the PCAP, but in a more readable format. And let's have a look at the failed one. The failed one, there you can see here, okay, this one is failed. You can see what the test case is doing, and you can see also what goes wrong. In this case, nothing received till the timer timeout. So we have expected that there's a message charge parameter discovery response is coming within the timeout, and it's not. So something goes wrong. In case of our XML document, you can have also a look at the commands which were in the beginning of the communication, because it could happen that a fault comes later, but the problem occurred a few messages before. So you can have also a look here at the message before. May this timeout is not the reason for the command for the request we have sent. It maybe the timeout is coming also from one of the other messages which were before. So you can analyze these messages here in the total. Okay, so can we have a look at the structure again?
Yes. Otherwise, we have also a log file. This log file is the whole overview of all the messages and all the events that happened. Not only the XML message of the data that we sent or received that we can see in the data log, but everything. Every little dot that we also can see in the state view, we have it in the log file. Everything that is at the bottom of the log file is also in the log file. Every PWM change, every change of PWM relevant data, and yeah. So we have everything here in a log format, readable format, with the timestamp when it happened, what it was, and what the information is.
Okay, so thank you all for looking or watching our presentation. Thank you, Jeff, for showing the program and the software, and also the rest of the test cases and so on. You can find our first videos still on YouTube. The links are on LinkedIn and also on Xing available. You need to look under Eclipse Signer. Also, the Eclipse Signer website will show you the links to the YouTube videos. We will also load up this video to YouTube so that you are in the situation to review it as long as you want. If you have any questions, comments, whatever, please send us an email or use the boxes under the videos or here also under this live presentation. But I'm not sure if it's stored under the live presentation. So the best case is to use the email. And again, a very warm thank you all for watching us. And yeah, hopefully we see us soon. Bye.
Bye.